We are on lesson 4 of chapter 8, which is point-slope form. So first we're going to use point-slope form to classify a line, then we're going to write the point-slope form of the equation, then we'll solve a real-world problem. Point-slope form is pretty straightforward. It focuses on a point, then it also focuses on a slope. So for example, if we have a point on the line that is, we call it x1 and y1, and we know the slope that we want to use as well, we could write an equation in point-slope form for a line that goes through that point and has this slope. The equation would be y minus y1, whatever that is, equaling the slope times x minus x1, whatever x1 is. Let's plug in some numbers to give you an example. If I have the point of the line 3, 8, and I want a slope of 2 to go through that line, I would write my equation as y minus y1, which is 8, equaling the slope, which is 2, times x minus x1, which is 3. So this would be a line with a slope of 2 that goes through the point of 3 and 8. Let's try these out. It says use the point-slope form of each equation to identify a point on the line that passes through and the slope of the line. So for example, if we have y minus 9 equaling negative 2/3 times x minus 21, if you remember back to our point-slope form, we are subtracting y1 and subtracting x1. So on the left here we are subtracting y1, meaning we are subtracting a positive 9. So I know my y equals positive 9. We are subtracting x1 over here, which is positive 21. We're subtracting positive 21. So that would be 21 for x and 9 for y. In point-slope form, my slope is located right here in front of the parentheses. So that would be the slope right here. So we'd say m equals negative 2/3. So over here we can do the same thing. We have y minus y1, so we're subtracting a positive 2 for y, x plus 8, so that's going to change it up a little bit. If x was negative 8, it would be x minus negative 8, which we know turns into a positive 8. So x therefore must be negative 8 on this point. So this is our point, negative 8 and 2, and then our slope would be 3. Now we get to write a point-slope form for an equation. So it tells us to write a point-slope form of each equation with the given slope that passes through the indicated point. We need a line with a slope of negative 2 passing through positive 4 and positive 1. Remember, point-slope form is y minus y1 equals the slope times x minus x1. So if we start with y minus y1, here's y1, which is just a positive 1. So we'd have y minus 1 equaling the slope, which is negative 2, times x minus x1, so x minus positive 4, so x minus 4. And there's my point-slope form. This would be a linear equation that passes through 4 and 1 that has a slope of negative 2. Now we need a line with a slope of 5 passing through negative 2 and positive 4. So if we do y minus y1, that'd be y minus positive 4, so y minus 4, equaling the slope of 5. And we'd have x minus x1, so x minus negative 2. Then we could turn minus negative 2 into plus 2 here. So this would be our point-slope form equation. Now we can solve a real-world problem. It says, suppose that laser eye surgery is modeled on a coordinate grid. The laser is positioned at the y-intercept so that the light shifts down 1 millimeter for each 44 millimeters it shifts to the right. So it's down 1 millimeter for every 44 to the right. The light reaches the center of the cornea at the eye at 125 and 0. It says write an equation for the light beam in the point-slope form and find the height of the laser. So remember our point-slope form, it's y minus y1 equaling the slope times x minus x1. First, let's find that slope. Here I see it shifts down 1 millimeter. For each 40 millimeters, it shifts to the right. Rise over run would be negative 1 for going down, 40 for going to the right. So this would be our slope, negative 1 over 40. And here's the point on the eye that they want to reach. So if we did y minus y1, it would just be y minus 0. So y minus 0. And we know that if we do y minus 0, we can just do y. So y equals the slope, which is negative 1 over 40, And that would be times x minus x1. So x minus 125. So this becomes my point slope form equation. We plugged in all of these numbers. Now we need to find the height of the laser. Well, what could we use to help us figure that out? Well, it tells us that the laser is positioned at the y-intercept. So what do we know about the y-intercept? Well, I know at the y-intercept, x equals 0. So we can make x 0 and solve this. So we can rewrite this without the x here. We just have negative 125. So our equation would be y equals negative 1 over 40 times 0 minus 125 is just negative 125. So if we do the multiplication here, this would turn into y equals negative times a negative gives us positive, so positive 125 over 40. And if we do that division, that's going to give us y equals 3.125. And since this is measured in millimeters, we're going to say 3.125 millimeters. So that'll be the height of the laser when we start.